It's with great pleasure I welcome you back. As of last time we were together, we were talking about matter classification, and we saw how different substances can be classified under matter. Before you have a simplified version of what we discussed last time, matter is broken into two major categories: pure substances and mixtures. Pure substances are further broken down to elements and compounds, and mixtures are broken down into homogeneous and heterogeneous mixtures. We also said something very peculiar. We said that pure substances and homogeneous mixtures, they share one common feature. They have uniform chemical and physical properties. So both of these have uniform chemical physical properties because the consistency of the material is the same throughout. But on the other hand, heterogeneous mixtures are not uniform and therefore they do not have uniform chemical and physical properties. So today we are going to see and we're going to identify what are chemical and physical properties. So, physical properties are characteristics of a substance that we can observe with our five senses. Imagine looking at the chemical to your right, which is sulfur. What can we say about it? The first thing we can describe is, for example, color. Color is an example of physical property. Different chemicals have different colors. Texture. Just by touching it, you can actually identify what kind of texture the substance has. Smell. Even though we shouldn't be smelling chemicals, oftentimes they exert a very strong, pungent, or even sometimes very sweet smell. Taste. Whenever we taste vinegar, for example, we actually taste acetic acid. When we taste fruit, we taste citrus acid, so on and so forth. Hardness, how hard it is, or how soft for that matter. Solubility, meaning how if it's able to dissolve in different substances. And the last three are a little bit more difficult to decipher. Density. If I give you two objects and you hold them in your hand, you can clearly see which is more dense and which is less. In other words, it's a characteristic you can observe with one of your senses. The same thing with melting point and boiling point. You can clearly see when a substance melts and when a substance boils, something you can observe with your five senses. All of these can be used to actually identify the characteristics and the properties of a particular substance. On the other hand, chemical properties are the characteristics of a substance that can be observed when it participates in a chemical reaction. In other words, these are reactivity characteristics. In the regions, you're often going to find chemical A, whatever that is, reacts with chemical B. Whenever you see that magical word reacts, you automatically know it's going to be a chemical property. A couple of examples include oxidizing. So chemical A, for example, whatever it is, oxidizes and rusts. That shows reactivity with oxygen. Combustion also shows reactivity with oxygen and the release of carbon dioxide and water. Acidity or basicity. That's another chemical property because why? It's got to interact with an indicator. So that's a chemical reaction. Radioactivity. Again, it must react with something in order to give off radioactive particles. And then finally, a reduction, if it undergoes reduction or oxidation. These are all reactivity characteristics that must react with other things in order to be able to decipher them. So these are properties. If you notice the common theme here, properties are always characteristics. They describe something. Physical, something you can look at, something you can feel for, or something you can smell, taste. But chemical is something that shows reactivity. Chemical physical properties are completely different from chemical and physical changes. Please do not confuse the two and read the question carefully what it's asking. So what are physical changes? These are alterations in matter that do not change the chemical composition. In other words, one example is paper ripping. Imagine we take a piece of paper and we rip it into 100 pieces. Well, did we really? We altered it in some fashion, we made it smaller, but we did not change the chemical composition. It was paper before we ripped it, it's paper after. You can use it in every single way. You could use the original paper, you can use it now, but it's simply in smaller pieces. Plastic bending. You can bend plastic. It was plastic before, it's plastic after. You didn't change the composition. When you crush a can, you physically alter its shape. However, you do not change the chemical composition. Glass breaking. It was glass before, it's glass after. It was transparent, it is still transparent. Something dissolves. When something dissolves, it disperses throughout the medium and it breaks apart. However, you can remove the water, you can remove the liquid, and you can obtain the original matter. You still have not changed the chemical composition. In other words, NaCl outside of water, it's still NaCl inside water, dissolved. And any phase changes, that's a big one. You have to remember this. Any kind of phase change, melting or boiling or evaporating, same exact thing. Why? Let's say, for example, ice cube is melting. It was water before, it's now water simply in liquid form. So it was water in solid form, now it's liquid form. Vaporization or boiling. It was liquid water before, now it's gas. Condensation. It was gas vapor before, now it's liquid. Freezing, it was liquid, now it's frozen solid. It was water before, it's water after. And you're going to see what sublimation is, but that simply is going from solid to gas state directly. So please make sure you remember that. Any kind of phase change, that is a physical change because you're not altering the chemical composition of the material itself. On the other hand, chemical changes, these are alterations to matter that do alter its chemical composition. You're now changing it, and therefore new matter is formed. You've created a new product, a new material. What are some of these examples? When you burn a piece of paper. As opposed to before, when you simply ripped it and you did not change the chemical composition, when you burn it and you create ash, it is now something completely different. You can no longer use it to write or store information on it. Souring milk. You can never get back the original milk that you had. It is completely soured. Digesting food, the same thing. After you've digested food, you've completely changed it and you cannot get the original food back. Cooking, the same thing. You cannot cook something. You can't get the original raw materials back. Baking, rusting. These are all examples of chemical changes, and you formed now new material. When you rust something, you take a piece of metal and you react it with oxygen, and that actually occurs naturally, and you now have iron oxide. You can use a rust remover, but that just simply removes the rust and it exposes new layer underneath this. You have not altered it. So, as you can see, chemical and physical changes are very different than chemical physical properties. Properties are characteristics, changes are alterations that are based on chemical alteration or not of. So now, going back to our matter classification, which is right over here, we have to now see where, for example, these take place. So, between substances and mixtures, these are physical changes. You can go back and forth between substances and mixtures, and the only thing you've done is physical changes. Because why? What's a mixture? Two or more of these substances in physical proximity, close together. What can you do? You can take this mixture and separate it back into pure substances. Allow me to give you an example. Let's say, for example, you have iron, okay, and you mix it now with sugar. Both of these were pure substances, iron and sugar, and you mix them together, now you form the mixture. But what can you do? You can take a magnet and simply run it across the surface and extract the iron from the sugar, and you separate it back into pure substances. In other words, you have not altered the chemical composition. You have not altered the chemical consistency between these two. However, between elements and compounds, you always have chemical changes. When you go back and forth between elements and compounds, this is always going to be chemical. Allow me to please give you an example. Remember we said water last time, that is a compound. You can take this using electrolysis and break it down to hydrogen and oxygen. Okay, it's going to be diatomic, and we can do something like that. Okay, but notice how the properties are completely different. These are two different things. Hydrogen and oxygen are highly flammable, whereas water, you can actually use it to put out a combustion reaction. So when you take, let's say, for example, a compound and you break it down to its elements, you have performed a chemical change. You've completely altered it, and you have completely altered the chemical and physical properties that make up that material, and therefore that is a chemical change. In class, we're going to speak a lot more about chemical physical changes and chemical physical properties. Thank you so much. See you in class.